Hello, and welcome to Game Revolutions, the series where I take a video game that I started writing in high school and I improve it, using knowledge that I have gained in the interim. As you may well know, I have temporarily removed game elements so that I could focus on double buffering and fast scrolling. Wow, that's fast! With that accomplished, it's time to start adding those game elements back. And today, we add back the car. And not only are we adding it back, we are going to improve it. Be free, my friend. Today we're going to go over a couple basic utilities that I wrote to help adding it back and making it cooler. And we're going to make it cooler. Let's watch!
So you want to be a player, but your wheels ain't flying. You gotta hit us up to get a pimped out ride. You've got to pimp my ride. Damn right. You've got to pimp my...
Here's a shot of a previous version of this game from before I started doing any of the off-screen buffers and stack blasting. When I started doing those things, I started removing elements like the earth and the enemy and the car. But I wanted to show these elements again, in particular the car, so we see what I'm going to be adding back. The only animation that the car does are these reflectors that go around the wheels. And so I'm going to talk about how I made that work previously and my new idea for how to make it better. The original version of the code used this table to describe where the reflector needs to be drawn. So each of these words, the first byte, the high byte, is an x coordinate and the y byte is a y coordinate. So there's a total of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 locations that a given reflector can appear in a given wheel. So this table is good for one wheel, and what I did is, since the design is cyclic and the wheels are out of phase, I would have one wheel be here, and the other wheel would be wherever this is +6. And so, of course, everything would wrap around as we go around the edge. The code to read from the table is here, and on entry B represents the index into that table that we're currently at. And so this would keep on incrementing each frame, so we would get the animation effect. Since each entry is 2 bytes, we multiply B by 2, we load X at the beginning of the table, add B into X. This will then change the register B to indicate how far the car has moved to the right, because you can with the joystick move the car a little bit to the left or a little bit to the right. I then multiply that value by 8, so we're now talking about a real x coordinate and not just a byte offset. And now I'm ready to read the 2 bytes out of the table. First byte will tell me the x location, the x offset, which I then add to that value I previously got, depending on how far to the right the car has moved. And then I fill B with the y coordinate. That routine is ref020, and that gets called twice, once for each wheel. And in between the calls, you'll see here is where we add 6 to our index so that the wheels are out of phase. Also, for the second wheel, we have to subtract by 16 bytes, because that's the distance between the 2 wheels. The table is tailored to work with only one wheel, so we have to do a little fix-up when we want to apply it to the other. But here's the kind of crazy part. We're grabbing XY coordinates so we can call my pset routine. I am doing pixel setting. How expensive is pset? Well, here's pset. The very first thing it needs to do is convert, I guess, from pixels into bytes. And goodness gracious, here is our convert routine. Fair bit of math there. Apparently the color that we want is stored in that variable, and then we do whatever this is doing. And since we're doing a single point, we gotta call this thing twice. What is PSO10? I don't know, but it does all of this. I am sure there's a better way to do this. But even if I tried to do this in a better way, I think the best way is to just stop it. Let's get back to the bytes. Rather than go through all of this, each time we want to set one point of one reflector, let's just treat the car like an animated sprite. Any good auto mechanic needs the tools of the trade. So I have a little basic utility here that will allow me to examine a scene. So if you look up here, you'll see a little blinking cursor. I'm gonna shift this thingy down here, and I can start inspecting the car. Oh, look, the car now has some blue in it. You see this blue here? Got some blue. You know what I was doing before? I have 4 colors in P mode 3. I was only using 3 out of the 4 colors. I mean, come on. So now I've got some blue down here. And what is the point of this blinking cursor? Well, this is a way for me to quickly take some image that I used BASIC to draw and then examine it. So for example, if I wanted to know where that new blue part begins, I could move the cursor here. I hit the space bar. And now it's telling me the byte offset in terms of X and Y. So it's 4 bytes to the right, A3 bytes down. And then this does the math and multiplies the Y times 32 and adds the X. So that's the full offset into the screen buffer. And then this just adds that offset to the beginning of the screen buffer. So if you take this and add E100, you get this. And finally, this is the value of the byte that I'm over. So like if I went up a bit, now the value is 55. And if I went like over here, over one of the rims there, now the value is F. So the idea is that this lets me know what section of the screen I might want to poke and add to my FCBs for my sprites. And it'll also let me know the value of the bytes too. So here is my magical idea. This top part of the car will remain static. So I'm just going to add that to my code once. And when I stack blast, I'm just going to stack blast that static portion. But I'm going to have the whole bottom portion be dynamic. This is where my reflectors are going to go around on the wheels. And rather than tracking the individual locations of the reflectors, I'm going to draw each frame in BASIC. And for each one, I'm going to take that bottom half of the car, poke that into memory, save it out as a binary, convert the binary to FCBs, and then I'll have like 12 different versions of the bottom of the car. And so I can use this to kind of tell myself, all right, which bytes do I need to poke? Which are the bytes that are going to be part of that dynamic part of the sprite? And as I was doing this, I was thinking, well, you know, I'm going to get some animation for free if I want it, because this whole bottom half of the car, even though it's only the reflectors that I care about and they're the only parts that's animating, I could actually animate any other part of this for free and the code would be none the wiser. It doesn't care because I'm still using this block of bytes, 12 different variations of this block of bytes. So I could do anything. And so I had the idea of having like a little police light marquee kind of flashing thing here between the wheels. So not only do the wheels have this reflector to sort of make it look like it's moving, but then we would have this like animation of the, it's free. It's like a Vegas kind of style marquee deal. How cool would that look? But before I do that, I wanted to point something out about this flashing cursor. If you notice, like wherever the cursor goes, it will change the colors momentarily to something different. Regardless of what colors it's over, it always knows how to change it to something else. What am I doing? Well, I'm just XORing it with 255, or you could also consider it, I'm just taking the complement. I'm just changing all the bits from 0 to 1. But you ask, how can you do that in BASIC? Does BASIC have bit arithmetic that you can do an XOR to 255, or that you can do a full bit complement of every bit in the byte? And I say, I don't think so. So I did it some other way. So here's that basic code. It's mainly just all the basic code to do the drawing, do the drawing, do the drawing, do the drawing, do the drawing. And then like it's down here where I have a loop where I can like cursor over things, and you'll see I can use the arrow keys, or I can use a shift arrow to skip a little faster along the screen so I can get where I need to go quicker. And then I do a little arithmetic here to figure out the byte that I'm over. That's the byte offset. I add that into E100 to get the actual byte location. I peek there, that gives me the byte value so I can print it when I need to. And then I was thinking, all right, I need to poke into that location the complement. And I was thinking, oh man, I'm gonna have to write all this basic code that will go through a number and convert it into binary, and then flip all the bits from the binary representation and then convert it back into decimal. And then I thought, whoa, I can do this in one line in assembly. I can do this in one line in assembly. If this whole thing were coded in assembly, all I need to do is do a complement the B register. And I thought, well, why not just make a simple assembly language routine that BASIC can call? I get the parameter BASIC passed me, I comb it, and then I send that back to the floating point accumulator, and I get out of there. And so that's what I did. So in order to get that cursor value, I just call my assembly language routine with the byte value as parameter. And then I can poke it right in there. I do a little pause, I poke the original value back, I do a little pause, and then I loop back up. And as soon as the user decides to hit the space key, that's when I move over to 1200, and then I print the values of everything. But then I was thinking, oh my gosh, so what, I'm gonna have to load M, this com helper assembly language routine? I don't wanna have to do that. And then I decided, okay, I'm not going to. It's so tiny, I can just put it inside the BASIC program. So I call LWASM, and I don't tell it to output a DECB binary. Instead, I have it output the format of hex. Let's run this and see what it does. It generates this text file here, comhelperbytes.txt. And here it tells me the location where the byte stream starts, and then it just gives me the byte code, and that's it. So I grab that, and I added it as data. And one of the first things I do in the program, I go sub 2000, which pokes that data. No separate save M, load M, space taken up on the floppy drive, self-contained. And that brings me to my next basic utility. This is the thing I can use to actually poke those values for the sprite into memory and save them separately. So based on what I got from that byte inspector utility, I know that my x low is at 3, my y low is at A3, my x high and my y high are there of those bytes. I can calculate the size. And I'm going to start to generate a bunch of bin files. So first I use my basic code to draw all of the static stuff, and then I prepare for the animations. There's going to be 12 frames because there's 12 different places for the reflector to be. So I have data that gives me where the X and the Y locations are for one of the wheels. And these are those locations. I stick those into arrays, and now I start to do my animation. So the first thing I do is I p-set that to this color. This will be yellow. I do my little out of phase calculation. I add 6 and I wrap around. That gives me the X2 and Y2 for the other wheel. I p-set those. And then some craziness. So this is going to be my little marquee / police siren light type deal. I'm going to have it be 4 colors. J is going to go from 0 to 3. Starting at x coordinate 34 and moving forward on this line, I'm going to make the color change. The starting point for the color is going to be based on my frame number. And I'm going to do it so that I get the same set of colors for the first 3 frames, and then a new set of colors for the next 3 frames, and then a new set of colors for the next few frames. And I'm making use of an interesting fact that I can pass a color here that's invalid, because BASIC will kind of wrap them around for me. So you're supposed to only pass colors 1 through 4 here. This is actually going to exceed 4 at some points, but BASIC will wrap that around to 1 for me, so I don't have to do anything complicated. Okay, so we're still in frame I after doing this drawing, and now it's time to poke. So I've got my loop to poke through that rectangle of bytes. I've got to poke them somewhere in memory that I can save later. So why not poke it at the beginning of screen memory? At least that way I get to watch the progress, and I find it quite soothing. After everything is poked, I make a unique file name. I save them the file. I erase the current location of the reflectors so that in the next frame it will look like they've moved to the new place. And that's it. I do that 12 times and I should end up with 12 files. Let us run it. So here you see what we're drawing in BASIC, and here you'll find where we're poking. So we're kind of flattening out that rectangle. So this bottom rectangle here gets flattened out into contiguous memory. It gets poked here, and each time through it gets saved to a new file. Here's my little marquee thing, kind of right next to the reflectors. And then when this animates, oh boy, it's gonna look like a real cop car, a real moon cop car. All right, so with that done, I should see a bunch of ref files. And there they are, refs 1 through 12. Now what do I do with these? I want to convert them to FCBs. So I wrote some simple Java code that'll go through a binary file. It'll skip past the preamble, ignore the postamble, and it'll generate a bunch of FCB statements. And then I can actually hand pick the things that are necessary and remove the things I don't need. And it also does one other thing. It will reverse the lines. So assuming that each line doesn't need more than 8 bytes, I can make it stack blasting ready by simply reversing the lines and leaving all of the byte orders exactly intact. Yes, I'm going to stack blast. So I ran that code not only on the different reflector ref bin files, but I also ran it on the original sprites.bin file because I didn't want that sitting around in here either. So here's what we've got now. This car.dat, this came from sprites.bin. This is the static portion of the car. And you'll see I commented out the bottom part because the bottom part is going to be chosen from one of the 12 frames. I'm going to keep a variable here that tells me which frame pointer I'm on. And here are the frames that were written out by that Java code. So this will be frame 1, frame 2, all the way down to frame 12. And here's all the other stuff. We got the Earth, the enemy, what holes look like when they get blown into the ground, what the replacement of the holes look like when they get blown in the ground. I might end up actually not using this. I'm not sure yet. So I don't have that annoying include bin thing anymore. Now I have bytes that I can actually look at and chop up and think about in an easier way. And finally, that brings us back to our main loop. So each time through the main loop, we update our loop counter. Then we do this, we'll update the car bottom frame pointer, which simply advances the pointer by 30 bytes each time, since that's the total number of bytes for each frame of the car bottom. And we wrap around to the beginning if we hit the end. We rotate the mountains or buildings, we rotate the ground, and finally we copy the car. And for this piece of the drawing action, I just completely unwound the loops. So the car is divided up into 6 rows at the bottom and 5 rows at the top. And they each have a different place to pull from for the bytes. So the bottom comes from that moving frame pointer. And so I just do 5 bytes at a time since each row is 5 bytes worth. The S is pointing to our source buffer, and the pull S does the advancement of S automatically for us. U points into the screen buffer, and so each time I push, I then need to advance U to the next row, or I should say perhaps the previous row, since U is going up, 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 up. So we do 1, 2, 3, 4, 5, 6 rows there. And then the top of the car, that just comes from car.dat, that static buffer. Same as before, 5 bytes at a time. And we do this for 1, 2, 3, 4, 5 rows. And that is it. Are you ready? Are we ready to see the result? Oh my God, that's incredible. That's incredible. Look at all those colors. You can even almost hear the police siren as those lights streak across the car. This is the makings of an epic game. But at what cost? We must do our performance check and see how this new code is affecting our frame rate. 3E5B. Nope, breakpoint changed. 3E6A and 3E6E. All right, so before the sync, frame 6479 at around 191. Still at 79 in the V blank. 80, 191, 80 V blank. 81, 191 V blank. So it looks like we're not skipping any frames. We're certainly using some more horsepower. But actually a lot of the time the beam Y is at 170 something. Not too shabby. Also, we can now see the car in slow motion. We can see that marquee slowly moving. We can see those reflectors. Because I don't know if you noticed, but holy cannoli zizzins, the speed of the car now compared to before is so much faster. I hope you enjoyed this journey to tricking out our car, and thank you as always for watching. Hello and welcome to Game Revolutions, the series where I take a video game that the series where I work on a the series where I take a and we are going to start with Oh my God. Let's see what we can do with it now. Whew. Be free, my friend. Today we're going to add some bling. God, I don't know what I'm saying.